I've been a bit naughty, I've changed my topic. I want to start off by sharing with you one of my absolute favourite inspiring people, Jacob Bronowski. I hope you've heard of him. The Ascent of Man is the series that he made. This is episode 2. And in episode 2 he stands on the island of Samos, which is where Pythagoras was born, and talks about Pythagoras. And he starts to do a demonstration with tiles for the Pythagorean theorem. And once he's done this, he stops and he says, in his beautiful method of delivery, he says, now we have a square on the hypotenuse, and we can of course relate that by calculation to the squares on the shorter sides. And then he has a kind of a bit of a wink to the camera, and he says, but we don't need any calculation. A small game, and then he pauses, such as children and mathematicians play, will transpose a triangle here and a triangle there. And then he shows the game. And so my talk is called Games Played by Children and Mathematicians. Young children are not afraid to experiment. They're not afraid to ask why. I always ask my students, very mature, serious students, to think about their younger brothers and sisters who go, why? And young children also demonstrate surprising concentration skills when they work on problems. So I believe it's really important to bring childishness back into high school. I firmly believe this. Here's one of my favourite childish type lessons. I hope you've seen this one, Weihart's Wind and Mr. Ugg. If you haven't, please look at it today. Wind and Mr. Ugg. It is a very intriguing narrative. It's a sense-making challenge. It's a childish game played on a Mobius strip. It has a surprise twist, it has a motivation to explore, and there's really deep mathematics beneath it. It's an instant 30-minute lesson. You just need a bit of paper, a bit of glue, and you can replicate this. Every single time I've done this lesson, students go home, they tell their parents, they tell their brothers, they tell their sisters. Even better, the next day they come and tell me, I liked Weihart so much, I found this one. I found the Doodling. Okay? There's many lessons on doodling. So Weihart really invokes that sense of play, and there's a role for it in your high school mathematics classroom. I believe we need more paper folding. There's not enough paper folding. The school that I've just gone to, that I've just moved to, very high performing academic classes, I've discovered my Year 12s cannot fold a square. They cannot create a square out of an A4 piece of paper. They just haven't done any paper folding. So we definitely need more of it. Here's my favourite one. I learnt this from Peter Hickey. I've written up about it on my blog. You can actually demonstrate the index laws with a piece of A4 paper, and then you can take it to the next level and ask your students to think about negative folds in origami and actually do the negative index powers. It's great fun. Inverse functions. You can have a terrific time with pen and paper. So what you need is a piece of paper. That was the challenge for my Year 12s, to create a square piece of paper. I wasn't expecting that. A lead pencil and a coin. The trick here is, the reason you need a coin is you get them to create a square piece of paper, they fold it on the diagonal, you get them to do a very accurate graph in lead pencil, quite heavy on the lead, then you get them to fold it, and you take the coin and you scratch the lead off, and of course it does the reflection. This is an activity, I'll talk a bit more about this later. Weihart again has got the most beautiful paper folding proof of Pythagoras. And while also I'll mention, she's also got a fantastic animation showing what happened to the guy who discovered that the square root of 2 was irrational. What's a great way to learn about circles? Use circles. It's amazing how many kids don't touch paper circles. A fantastic asset that you need in your classroom. Teach circle geometry with circles. Beautiful ways to do it. This is an exploration that you'll see often done only in lower achieving classes. Let's do a paper folding method, paper cutting method of looking at the area of a circle. I think this is suitable for a calculus class. You can extend this lesson to all your calculus concepts. I think every student should do this activity. Nothing beats childishness better than Sesame Street. This is my all-time favourite sublime video. It's called Fish, Fish, Fish. I'll give you the links at the end. I show this to my Year 7 classes. I show this to my Year 12 classes. It's got content all the way. From the sublime to the ridiculous. James Blunt singing You're So Beautiful to the tune of You're So Beautiful about his love for an equilateral triangle. It's hysterical. The best thing my Year 10 class and I have done is watch a Year 5 video called I'm a Parallelogram. It's the most addictive song that you'll ever see, and it just has such a sense of fun into the geometry. Really recommend that one. Want a sense of fun in your classroom? This guy, you want this guy in your class, Dr. James Grimes. Does a lot of things on a YouTube channel called Numberphile. Every week there's 2 or 3 things that are just so exciting. You can build short lessons, long lessons. It's amazing how it links into the curriculum and how it extends. This one is the mathematics from Good Will Hunting. Those of you who've seen the movie, he's a cleaner and he's got to solve a problem, and this is the problem that he solves. Well, you can bring this problem into your class and do it. It's a great pen and paper exercise. Okay, is this just mathotainment? Which is what some of my colleagues used to accuse me of doing. Is it mathotainment? Well, let's have a think about it. This lesson introduces students to topology. These Sesame Street videos can actually introduce lessons and discussions on abstraction and what we're actually doing in mathematics. I got this idea from a guy called Stephen Strogatz, who's one of the top mathematics writers in the world. If you look up on Google from fish to infinity, he's the one who pointed at this video as a good starting point, the number theory. Vi Hart's work is terrific. She always asks deep mathematical questions at the end and challenges the kids. You've folded something, is it true? How do we know that it's not just an artefact of folding? So really good questions there. So deep thinking about proof. Only got about 1 or 2 slides, which is good. Narrative. All right, I'll go faster. Is this just for little kids? Absolutely not. I find that many of the higher achieving classes or senior classes have never done these types of activities. They love them. You've just got to convince them to touch the paper. Once they do, they love them. What's even better is you'll be amazed what they do to your idea of what you're going to do in the lesson. They carry it way further than you ever imagined. So it's very rewarding. My goals for an inner child lesson must be engaging. There must be something students do, so don't just watch a video. It's got to be something you can stop and pause and do something with and extend. And it must have potential for extension. Why else is it good? Kids get to see your inner child come out. I think that's what you want. It's something that Eddie was saying about you've got to share that passion, and inner child activities give you a chance to do that. One last line. Homer Simpson visits the land of chocolate and goes wild and imagines how beautiful the world would be if it was just made of chocolate. Seymour Papert, one of the great educators, encouraged us to create a place called Mathland. And he said if students lived in Mathland, they would have no difficulty learning maths. And so his challenge is us, how can we create Mathland? That's what it's really about. And there's my quotes.